IMO 2025 Problem 4 Episode 2. Part 3. Fixed loop or steady state set. Phi of x equals x. If and only if x equals 6m. Where m is odd, and 5 does not divide m. We will determine if there is any decrease or increase before r gets to 1. First, decreasing steps. We will prove that a number cannot decrease into the constant loop f. Assume there exists n in a decreasing group such that phi of n is less than n. But phi of n is in calligraphic f. Enumerate the groups as in the picture. First, we prove that if phi of n is in calligraphic f, then n must be divisible by 4. Since phi of n is even, n must be even, so d1 equals 2. Assume 4 does not divide n, then n over 2, n over d2, and n over d3 are all odd. So phi of n is odd. Contradiction. Hence, 4 divides n. Step 2. With 3 not dividing n over 2 plus n over 4 is congruent to 0 modulo 3. But n over d3 is not congruent to 0 mod 3, since d3 is at least 5 and not divisible by 3. So phi of n is not congruent to 0 mod 3, but every element of calligraphic f is divisible by 3. Contradiction. Therefore, decreasing steps cannot lead into calligraphic f. Next, we determine how many increasing steps there could be before r equals 1. Assume n belongs to an increasing group and phi of n is in calligraphic f. Then by similar argument, 4 must divide n and r of n equals 13 over 12. Suppose a sub k plus 1 equals 13 over 12 times a sub k. For k equals 1 to n, and a sub n plus 1 is in calligraphic f. Note that 13 over 12 equals 13 over 2 squared times 3. Each multiplication decreases v2 by 2, versus 3 by 1, versus 5 stays at 0. After n steps, to have v2 equals 1, versus 3 at least 1, and v5 equals 0. We must have v2 of a 1 equals 2n plus 1, versus 3 at least n plus 1, versus 5 equals 0. So a 1 must have the form 2 to the power 2n plus 1, times 3 to the n plus 1, times t, which equals 6 times 12 to the n.